Think back to just a year or two ago. We used to wait minutes for a single AI output.
Oh, yeah, and it would usually spit out a heavily distorted image, right?
Right, usually with like 7 fingers. Beat.
Yeah.
But today, the landscape is completely unrecognizable.
It really is night and day.
In under 5 seconds, we are reverse engineering architectural floor plans. We are literally bending historical time itself.
It's a profound, fundamental shift. We moved from basic novelty to true industrial precision, and we did it in the blink of an eye.
Welcome to this deep dive. Today, we are exploring something highly specific for you. We are deconstructing the newly released Nano Banana 2 Mastery Guide.
Which is packed with some incredible data.
It really is. We're breaking down Google's shift to the Gemini 3.1 Flash architecture. We will explore stress test results covering historical accuracy.
And that includes some really complex Japanese text translation tests, too.
Exactly. We will also outline the definitive 6-part prompt formula. And finally, we will reveal why you actually shouldn't abandon the old Pro model just yet.
It is a massive amount of ground to cover. But the implications for your daily creative workflow are absolutely staggering.
Let's start with the foundational shift here. Back in March 2026, Google made a very surprising move.
Yeah, a lot of people were confused by it.
Right, because they completely replaced their flagship image model. They swapped it out for a seemingly lighter version. Why would a massive tech company downgrade their main tool?
Well, it only looks like a downgrade on the surface. They introduced Nano Banana 2. Internally, developers call it Gemini 3.1 Flash Image.
Okay.
The entire strategy here was about aggressive computational efficiency. You are looking at a model that costs 50% less to run.
Wow, 50%.
Yeah, half the cost. But it generates images 3 to 5 times faster. It officially replaced Nano Banana Pro as the default engine.
Okay, let's define some technical terms for the listener before we go further. What exactly is this Flash architecture?
It is a lighter, faster digital brain built purely for speed.
So it trades deep, layered complexity for rapid, high-volume output.
Right. And that speed unlocks entirely new capabilities. Because it's so fast, it actually introduced a massive new operational feature. It is a feature point search grounding.
Let's define that one too. What is search grounding?
It means checking facts on Google before drawing the image.
Beat. That is fascinating. We should unpack how that actually works under the hood. You're saying it researches the topic before it renders a single pixel.
Exactly. Historically, image models just guess based on past training data, right? But this model actually pauses its rendering process. It pings a live Google Search API. It retrieves textual facts about your prompt.
So it pulls real-time data.
Right. Then it injects that verified data directly into its latent space. Only then does it start drawing.
The results are incredibly apparent in the historical stress tests from the guide. They highlight a specific experiment using the Giza pyramids.
Yeah, this test was mind-blowing to read about.
They asked the model to depict the pyramids across 4 distinct eras. How did it handle the deep past?
It handled it brilliantly. For 2560 BC, it rendered smooth white limestone.
Wow.
Yeah, it perfectly matched how archaeologists believe the pyramids originally looked. Then, for 1200 AD, it shifted the entire geographical scene.
What did it show for that era?
It showed a dusty medieval Cairo setting. It included desert caravans and heavily weathered stone.
Okay, what about the more modern eras?
For 1890, it actually mimicked Victorian black and white expedition photography.
Oh, that's clever.
Yeah, it showed classic explorers and old camel caravans. And then for 2025, it rendered paved walking paths.
Like a modern tourist setup.
Exactly. It showed modern tourist crowds with smartphones. It even captured the sprawling modern Cairo skyline in the background.
So they asked it to draw the Giza pyramids across 4 eras. I assume the old Pro model just spat out the exact same dusty pyramid 4 times.
Exactly, because it has no concept of historical time. The old Pro model failed this test completely. It just hallucinated the generic pyramid shape over and over.
It is like replacing an artist who draws purely from memory. You replace them with an artist who actively researches at a library while sketching.
That is a perfect analogy. The new model anchors its visuals in verified, real-world data.
But does pulling real-world facts restrict the model's creative weirdness?
Not at all. It anchors the baseline reality first. This actually frees up massive amounts of computing power.
Because it's not wasting energy guessing.
Right. The model doesn't have to guess what a pyramid looks like. It uses that saved power for intense aesthetic creativity instead.
So grounded facts provide a reliable foundation, not a creative cage.
Precisely. You get absolute historical accuracy without losing the artistic flair.
We've seen how it understands the flow of time, but I am actually more curious about how it handles three-dimensional space.
The spatial reasoning is a huge leap here.
Right, because historically, image models are just flat pixel guessers. They don't know what a room actually is.
That brings us directly to the infographic tests. This is where the model's spatial reasoning gets pushed to the absolute limit.
They fed the model an image of a luxury supercar, right?
Yeah, it was parked under some pink leaf trees.
What was the specific prompt for this test?
They asked it to recreate the exact photography setup, but they wanted a retro 1970 instructional infographic style.
It actually deduced the inventable camera gear.
Yes, it reverse engineered the entire scene. It accurately diagrammed the direction of the natural light.
That's incredible.
It gets better. It identified that a 50mm moderate wide-angle lens was used. It correctly mapped the exposure settings from a single flat photo.
How did the older Pro model handle that same prompt?
It hallucinated entirely. It added a giant softbox light that clearly wasn't there.
Of course.
It added an extra tripod in the background. It was just guessing blindly.
Let's talk about the beachfront villa floor plan test. This one really stood out to me in the guide.
This test pushes the spatial reasoning into uncharted territory. They uploaded a standard 3D photograph of a modern villa.
Just a flat, forward-facing photo of a living room.
Exactly. And they asked for an architect-style blueprint.
A top-down floor plan.
Yes. And the model successfully inferred a massive, complex architectural layout. It logically placed a chef's kitchen and a hidden pantry.
Wow.
It mapped out a powder room and an infinity pool. It even mapped out roof solar panels based on the exterior shadows, all from one standard photograph.
I do have to push back a little on the educational test, though. The guide mentions a deep ocean zones infographic test.
Oh, right, the science materials.
Yeah, it generated highly detailed educational science materials. Should we really trust AI to teach science without human oversight?
That is a very valid concern. You always need human validation. The output was incredibly clean and visually organized.
But the facts might be slightly off.
Right. The AI is a rapid drafting tool. It is not a certified science teacher.
How is it inferring a top-down floor plan from a flat, forward-facing photo?
It's not just looking at the surface pixels. During its training on billions of architectural images, it learned advanced depth cues.
So it understands geometry.
Yes. It associates the angle of sunlight on a counter with structural depth. It knows a doorway strongly implies a connecting hallway behind it. It calculates probable spatial relationships based on strict architectural rules.
It maps invisible room structures rather than just copying surface pixels.
Exactly. It effectively reverse engineers the 3D geometry from 2D shadows.
Understanding spatial geometry is deeply impressive. But placing perfect, legible text within that geometry is a different story.
Oh, absolutely.
Historically, that has been AI's biggest failing.
Text has always been the absolute Achilles heel of image models. Older models used to see text as weird, abstract shapes.
Like a foreign language they couldn't read.
Right. They didn't understand them as actual alphabetical letters.
The guide covers a complex multi-object text test. It required 7 distinct objects clustered in one scene.
And each object needed clear, specific text printed on it.
And Nano Banana 2 handled the complexity beautifully.
It really did. It rendered all 7 distinct objects with crystal clear text. It even correctly mirrored a glowing neon sign backwards in a reflection.
There was a minor glitch with a luggage tag, right?
Yeah, there was a tiny mapping error. The text for the luggage tag appeared on a coat instead.
That's pretty minor.
Very minor. And a simple one-click retry fixed it immediately.
And the older Pro model?
The old Pro model failed this test completely. It gave torn boarding passes and absolute gibberish for text.
Let's talk about the in-image localization feature. This almost feels like magic.
It is arguably the most powerful practical feature for businesses. They uploaded a photo of a vintage German newspaper.
And asked the model for a direct translation.
Yes. And it delivered a perfect English translation seamlessly.
Did it look like a new digital font?
No, that's the crazy part. It kept the old, crinkled newspaper texture completely intact.
They also translated an English billboard into Japanese,
Right. And it meticulously maintained the original font style. It kept the corporate brand colors perfectly matched.
Natively in the image.
It did all of this natively within the pixels of the image.
Imagine localizing a massive global ad campaign in seconds. You do it entirely without hiring a graphic designer.
It's a game changer.
That is immense practical value for anyone listening right now.
It changes the entire workflow for modern marketing teams. You don't rebuild the digital asset from scratch anymore. You just seamlessly translate the pixels.
Is it actually repainting the pixels or just slapping a digital text box over the image?
It regenerates the underlying noise profile of the original pixels. It matches the film grain and lighting perfectly. Then it weaves the new text directly into the grain of the photo.
It physically rebuilds the text layer right into the image fabric.
Yes, it is total seamless integration.
We're going to take a brief pause right here. Insert mid-roll sponsor read here. All right, let's get back into this deep dive. Text localization gives you incredible control over words. But how do you control the specific visual objects populating the scene?
This is where we see a massive, unprecedented leap forward. Older models allowed 1, maybe 2 reference images at most.
Right, if you push it further, it just broke.
Yeah, the generated image would just break down. The textures would bleed into each other completely.
But Nano Banana 2 fundamentally changes the rules of the game.
Yes. It supports an incredible upgrade to 14 simultaneous reference images.
14. That seems incredibly complex for a neural network to balance.
It is mathematically staggering. They ran a complex test called the Zoo and NJI movie poster.
Walk us through the mechanics of that test.
They took 14 entirely disjointed source images. They had a rugged archaeologist, a local guide.
A monkey sitting on a chest, I remember reading.
Yeah, a muddy jeep, a glowing lantern.
Or binoculars.
Binoculars, an old map. They fed all 14 of these distinct inputs into the prompt.
And they asked for an epic cinematic poster.
Yes. And the model seamlessly synthesized every single element. It created one cohesive, hyper-realistic cinematic jungle scene.
With accurate lighting across all 14.
Exactly. Every single reference object was placed naturally within the 3D environment. The lighting on the monkey matched the lighting on the Jeep perfectly.
There is a very practical tip here involving Google Flow.
Right. If you use the Google Flow interface, use the @tag system.
How does that work?
You can type the @ symbol to link specific text prompts to specific reference images. It gives you absolute granular control over spatial placement. 2-sec silence. Whoa. Imagine processing 14 completely different visual references simultaneously and stitching them into one perfectly lit, cohesive scene.
It really is staggering when you think about the attention mechanisms required. With 14 inputs, how does it decide which object gets foreground priority?
It avoids prompt bleeding by relying entirely on textual hierarchy.
So the words dictate the structure.
Yeah, it uses the hierarchical weighting of the text prompt you provide to rank importance.
Your text prompt acts as the director, telling the visual props where to stand.
Exactly. You are the absolute director. The prompt is the definitive script.
With all this multi-object, text-heavy computational power, we have to ask the obvious question. What does Nano Banana 2 actually fail at?
It does have one highly visible Achilles heel: human faces.
Tell me about the hyper-realistic human portraits test.
The prompt asked for a highly detailed, intimate human portrait. It specified minimal jewelry, natural diffused daylight, and shot on analog film.
And how did Nano Banana 2 perform on those specific constraints?
It rendered the skin pores and individual hairs very cleanly. It was technically sharp.
Too sharp.
Almost too sharp. It felt incredibly clinical. It was heavily over-sharpened. It looked distinctly and obviously AI generated.
It completely lacked that organic human warmth.
Yes. And this is exactly why the older Nano Banana Pro won this round. Pro delivers much softer, highly organic results.
It feels more real.
It produces true-to-life, subsurface skin tones. It actually looks like a real, raw photograph.
So we absolutely shouldn't abandon the Pro model just yet.
Definitely not. And Google knows this. You can still access Pro very easily.
How do you switch back?
In the main Gemini app, you just click the 3-dot menu. Then you simply hit the button that says Redo with Pro.
That is a highly practical workflow tip. Let's pivot to the definitive 6-part prompt structure. This is how you systematically fix bad outputs.
Most people write incredibly vague prompts and then blame the AI for failing.
Right.
But the model just needs clear, structured instructions to succeed.
The guide outlines 6 specific architectural elements for a perfect prompt: subject, action, environment, art style, lighting, and camera or shot type.
Right. The subject clearly defines the main object. The action gives that object narrative context.
The environment sets the physical scene.
And the art style controls the overarching aesthetic.
And the last 2 are arguably the most crucial: lighting and camera type. You can specifically ask for an 85mm portrait lens.
Or vintage Kodak film stock?
Beat. Despite knowing this formula, I still wrestle with prompt drift myself. I will get lazy, forget to specify the lighting, and end up with generic, plastic-looking results.
It happens to absolutely everyone.
Yeah.
The machine only gives back what you explicitly put in. If you skip the lighting parameters, it defaults to a terribly flat studio look.
Why would an older, slower model be better at rendering natural human skin?
It comes down to computation trade-offs. Flash is heavily optimized for high contrast, sharpness, and raw speed.
And Pro.
Pro uses much heavier, slower processing for complex natural light blending. Flash optimizes for sharp speed, while Pro prioritizes natural, softer blending.
That is the eternal trade-off in AI right now. Speed versus organic softness.
If we can now create photorealistic, historically accurate, multi-reference images so easily, how do we prove what is real and what isn't?
This brings us to a crucial technology called SynthID. It is a critical piece of this entire new generation ecosystem.
Let's define it clearly. What is SynthID?
An invisible digital signature hidden deep inside the image's pixels.
So it is not just a visible, transparent logo stamped in the corner?
No, absolutely not. It cannot be seen by the human eye at all, and it is incredibly difficult to remove without entirely destroying the underlying image data. How does the detection mechanism actually work?
It is beautifully simple for the end user. If you upload a SynthID watermarked image back into Gemini, the system flags it instantly.
It just tells you.
Yeah, it explicitly tells you the image was AI generated.
There are major practical implications here for creative professionals.
Absolutely. If you use AI for heavy client work, disclose it upfront. It builds long-term trust.
For sure.
But more importantly, the watermark actively protects you as a creator.
How does it practically protect the original creator?
Imagine someone tries to pass your generated artistic work off as a real misleading photograph.
Like a deepfake.
Right. They try to claim it as real news. The watermark proves its definitive origin. It mathematically proves it was generated, not photographed.
It really feels like the beginning of an authenticity arms race on the internet. We will soon need specialized tools just to verify basic reality.
We are already deeply entrenched in that exact arms race. SynthID is just the latest, most sophisticated shield available.
If I screenshot the image or heavily compress it as a JPEG, does that kill the watermark?
No. Google engineered SynthID using advanced frequency modulation.
So it survives compression.
It is designed to survive aggressive cropping, heavy filtering, and standard digital compression.
The watermark survives resizing and most aggressive image compression techniques.
It is deeply baked into the mathematical file structure. It is incredibly robust.
Let's summarize the big idea here for the listener. Nano Banana 2 fundamentally shifts the entire creative landscape.
It really does.
It trades the ultra-soft realism of the old Pro model for raw, unparalleled speed. It offers incredible precision for text localization.
And it delivers truly mind-bending spatial and historical accuracy.
Right. It is the ultimate utility tool for complex, high-volume workflows.
It is significantly cheaper. It is exponentially faster. And it understands complex spatial instructions far better than ever before.
But you must keep Pro on the digital shelf. You save it for those rare moments when you desperately need true, organic human portraits.
Exactly. You have to use the right tool for the right job.
I want to leave you with a final, lingering thought today. We've seen how AI can reverse engineer an accurate, top-down architectural floor plan. It did it from a single, flat photograph of a living room. Beat. What happens when it starts generating structurally sound blueprints for massive buildings that don't even exist yet?
Wow.
What happens when it completely bypasses human architectural drafting entirely?
It changes the fundamental nature of design entirely.
You highly encourage you to try the 6-part prompt structure on your next deep dive into your own creative work. Test the extreme limits of the Flash architecture yourself. Thank you for joining the conversation.